diagrammatic information to describe the electric field strength and direction between parallel plates.
And between a positive and negative point charge. So this goes over 2 slides so that you're aware when you're copying your notes. Firstly, I'd like to make sure that you use a pencil when you're copying the diagrams, and there is 5 diagrams in total, 4 on this slide, 1 on the next slide. So an electric field is defined as a region of space around a fixed charge in which a force is then exerted on another charge. So the word field in science came from James Clerk Maxwell when he defined a magnetic field in the late 1800s, and we've used that analogy of field in electricity and points of charge. So the concept of electric field is introduced to explain the force that one charge exerts on another. As a force is involved, the electric field has a direction and is therefore a vector quantity, which will be mentioned in moving about in the next topic, vectors and scalar quantities. By convention, the direction of the electric field is given as the directional force on a small positive test charge placed in a field. So what you need to do is in your diagram is make sure that you draw the diagrams accurately with the positives and the negatives in the correct placing, and the lines are critical because they determine the lines of force or electric field lines. The more lines, the more densely the force is, or the more force there is situated in that diagram. So when we're looking at a parallel plate where there's a positive and negative plate, you can see that the electrons flow from, electric field flows from positive to negative. So these lines of force go from positive to a negative charge, and this follows from the fact that lines of force give the direction of the force on a positive test charge. Lines of force do not meet or cross. If the electric field is uniform, then the lines of force are parallel to each other. The concentration of lines of force is greatest where the field is the strongest, and I mentioned that on the previous slide. This is the region in which the magnitude of electric field is greatest.